Radiating from the Lone Star State and stretching from coast to coast and border to border, this is On Radio, the weekly download from your family of companies: CMS Wireless, Enertech, ET Tower, Legacy, and Mountain Wireless. Welcome to On Radio.
Well, folks, today we are thrilled and privileged to welcome Dale Shoemaker. Now, I used to call him Schumacher, but his name is Shoemaker, and it's actually spelled accurately Schumaker. And Dale is an engineer, don't hold it against him, who is the developer and the lead on a product called RiggingCalc, an entity called RiggingCalc. And welcome to On Radio, Dale.
Thank you, Jim. It's a pleasure to be here.
All right. So one of the things that we talked about wanting to be able to do was to raise the level of awareness about rigging plans to the people out in our industry, because there is a requirement, and I don't want to dive into big standards, but the industry requirement comes from ANSI, the American National Standards Institute, and they have a tower rule book for engineers called ANSI A1048. Is that correct?
Yes, sir. Yeah. It came out in 2016 to try to help standardize the way we build tower sites and the safety precautions that we take.
Yeah, and it really spells out the how of putting tab A and slot B together when you're working at elevation, and then it grades them, like in terms of how serious is, and so there's classes of rigging plan. So what is the first class, the most basic class?
Yeah, the first class is a class 1, and it means when you're lifting a gross load, which a gross load is all of the weight that you're lifting. So not only, maybe the mount or whatever item you're lifting, but also all the rigging. And
the rope?
The rope too.
The pulley?
Shackle. Yeah.
And so if you're pulling 100 pounds up, you're pulling 100 pounds down. So now that 100-pound load is 200 pounds, right?
Well, yes, sir. It's putting that much force back on the tower. So yeah. I mean, Jim's been educated on this stuff, and he's got it. Yeah.
No, I've not been educated. That's why I'm leaning on you, man. But give us an idea of what a class 1 rigging plan looks like.
Yeah, class 1 is when you're less than 350 pounds. You're required to have a rigging plan no matter what you're lifting. And we'll go over those other classes too, but class 1 is less than 350 pounds. And the standard says that it doesn't have to be written down, but you have to have a plan in place when it's a class 1.
So if I have a 65-pound antenna and a 100-pound rope,
yes, sir, I
need a class 1 rigging plan, don't I?
You do.
Yeah, because that's a lot of rope, that's a lot of pulley, that's a lot of downforce, that's a lot of upforce, and all of a sudden I put a tagline onto it, and I'm pulling away from the tower as well. The load that we're superimposing on the tower is well in excess of 400 pounds, isn't it?
Well, if it's in excess of 400 pounds, then you'd be looking at a class 2 rigging plan.
Aha! So it is graduated. And so who does a class 1 rigging plan?
Yeah, a class 1 rigging plan takes a competent rigger. So that's somebody who's been in the field a while, usually more than 3 years, and they've got a lot of experience rigging and working on the sites and lifting loads. And they're in charge of the lift. Yeah.
A person who actually knows how, and then they implement that know-how, and hopefully they share it with the guys who are working for them so that we can grow our people from the inside out.
Very much so. I mean, that's what the rigging plan part of it is about, is that you're all on the same page and you're working as a team underneath somebody who's competent, the competent rigger.
Yeah. And so then it moves into class 2. And let's just break it down real quickly. What is a class 2 rigging plan?
Yeah, a class 2 is a little bit more weight that's out there. They recognize that. So it's when you're lifting something that's less than 500 pounds. And again, you're going to have a competent rigger involved. But because this is a little more weight, gross load that's going on, it needs to be written down and communicated in writing and documented.
So as versus to, I know how to drive to the convenience store because I've done it 100 times. Now I need a map to get to that convenience store. And this rigging plan is actually just a written map that says, hey, I did the work and I thought about it a little more because it's heavier. So that's what I'm going to do.
You bet. Those rigging plans just show the equipment, procedures, and personnel that are going to be required to make the lift safely. Yeah.
Okay. And then we move to a class 3. Now we're getting into a little bit more level of serious, aren't we?
Yeah, we are. This is up to 2,000 pounds. So, you're
Mm-hmm.
lifting less than 2,000 pounds gross lifted load. And you need another person that's got maybe a little bit more experience. But the main thing is that they kind of can read and understand plans and forces and communicate to others in the industry. Yeah. Yeah. Like engineers and
Yeah.
other people that might be important. Yeah.
And when we execute that, now this is not only a written plan, this is a written plan with some numbers crunch to it as well, isn't it?
It is, yeah. You have to understand what you're lifting, and what that weight, like you kind of pointed out, it can be made up of a number of different things is. But then you got to understand how those forces really come back to the tower, because when you start putting pulleys and blocks and everything and pulling on it with tag forces, you introduce a lot of extra load on that tower. You want to make sure you understand that clearly and are using the right equipment that has the proper working load limits to support that load.
Sweet deal. And then we move into the big boys. So now we're talking about a class 4 rigging plan. We're talking about things like heavy loads, cantilever devices like gin poles, and things that actually change the dimensions, actually the risk of what we're doing, not only the risk to us, but the risk to the tower, the risk to the equipment, it's the risk to our customers. And so what are the requirements of a class 4 rigging plan?
Well, a class 4 at its base level kicks in when you have a gross lifted load that's greater than 2,000 pounds. You're greater than 2,000 pounds. But like you say, it can also kick in when if there's a special requirement going on, like maybe you're lifting off a mount or an appurtenance, something that's away from the tower. Lots of times, the majority of the time, when you're using a gin pole, you're going to be in that class 4 range where you really need to look at those forces that are not only in the rigging and the equipment, but are also coming back to the tower to make sure everything's safe there as well. And so you need multiple people involved with the right competency. So you've got your competent rigger who's out there on site and they're making sure everything's happening the right way. They're consulting with their qualified person to make sure, that they're doing everything right. And they're double checking things and giving all the information on the rigging back to that qualified person so they can check it. And that qualified person is then translating to the nerdy engineer that gets involved. And I guess I qualify as that, as a qualified engineer. It's somebody with a PE behind their name that really understands rigging in the field too, so that they can communicate well and understand the forces that are being put back on the structure.
When I communicate to our guys in the field, they say, how do I know if I need a class 4 rigging plan? And what I usually tell them is, when you feel like you're going to get in a ton of trouble if something goes wrong. A ton of trouble is 2,000 pounds, right?
It is. It's a ton, and it's a ton of trouble. Yeah.
Yeah, and stuff can really go wrong, and it spirals fast. And what do we gain when we have an engineer looking at that?
Well, when the engineer's looking at it, you've got one more set of eyes just on the rigging that's going on. It's not really their responsibility, but you've got another set of eyes for that. I mean, the main responsible people there is the qualified person, the competent rigger. But what they're really looking at is the forces that, kind of like you said, can get compounded back to the tower, and making sure that that tower is okay to support those forces that are coming back to it.
That's awesome. And so all of our people in the field need to know, if you're going to lift something that is over 300
yeah, 350
pounds, 350, that we're going to have a rigging plan. And
Yep.
if you're going to get in a ton of trouble, then we need some really highfalutin engineers to look at this, because we don't want to pull a tower over. Isn't that right?
No, yeah, we don't. And just to be clear, we will anytime you're doing any lifting on a tower, you require a rigging plan. When it's over 350, it needs to be written down, though.
Yeah. And so what about, it ain't such a big deal. We're going to use a boom truck or a crane or whatever we're going to do. What happens then?
Well, you're still lifting and rigging on a site, and so you still need a rigging plan there too. Generally, those are considered class 3 rigging plans, where you've got your competent person, they're on site, overseeing everything, and you've got a qualified person in tangent or in concert with the crane operator many times, making sure that everyth's safe to lift.
And two, the crane operators these days are really more equipped because of NCCCO qualification, but also because the equipment they're using usually is going to tell them how much weight they're lifting at any given point, how much stress they're putting on the crane, how much wind there is up at the tip height, et cetera, et cetera. Isn't that true?
It is true. They have some great equipment out there these days and great operators in training. We definitely want to take advantage of those systems and devices that they have at their fingertips.
Yeah, and I have to tell you, one of the things that I'm totally impressed by is that you and your team over at RiggingCalc saw a need. And you said, you know what? It's really hard for guys in the field and gals in the field to come up with a rigging plan like that. So let's improvise and create a methodology that allows them to be factually accurate, mathematically correct, and take into account all the pieces and parts of a rigging plan. And you did that and said, boy, this is just a big math problem. Let's automate it. Tell us about what the creation looked like.
Yeah, well, we knew that there were some issues in the industry, and we've been hearing about it and the root causes. They were looking at that prior to 2016, and rigging was a major problem with that. And we knew that a standard was coming out with a bunch of smart people had got behind it in A1048.
For
And
sure.
we wanted to be able to apply that in a way that, like you said, made sense, that could uplift the industry and the safety in the industry. And the way that, us engineers know how to do that stuff is kind of through math and using that in a way that we share it and make it usable for the folks in the field. So we came up with RiggingCalc.
And so, for our audience that may not know or understand, give us a definition of what RiggingCalc is.
Well, I mean, RiggingCalc is really just kind of a systematic way of putting together the information and checking the calculations to put together a rigging plan to make sure you're safe. I often liken it a little bit to TurboTax. Your taxes are really complicated, right? And it's kind of hard to understand all that stuff. But if you break it down in a systematic way and go through it and provide lots of little tool tips when you have questions and stuff like that you can click on, it's not as hard as you might think. And you can still get there and make the right decisions. So that's what we try to do with RiggingCalc.
So RiggingCalc at its core is a problem-solving computer program for folks in the field to do what they know that they need to do, but may not know how. Isn't that accurate?
Yeah, I mean, the folks in the field need to understand basic rigging principles and forces, but it'll really helps them take that knowledge that they have. I have such respect for the guys and gals in the field and their knowledge, but they can take that by using RiggingCalc and get it in a format that is compliant with the standards requirements, but also helps them just think through the situation and make sure they've done all the right things that they need to do.
Yeah, and they don't need a PhD in quantum physics to understand that, hey, all the forces that you're going to put on a tower are not evident at first. You don't learn this tower business in a day. And what we used to do is say, well, my gut feel is this will be good. And that doesn't work anymore because we don't have the level of success that has been bred into the program that shows us the actual forces on the tower.
Yeah, math is pretty black and white, and if you can kind of distill it down and get the good inputs into it, then you can aggregate those inputs and really understand how they're affecting the structure and affecting what rigging equipment you need.
This is the end of our first segment, and so I want to thank Dale Shoemaker for stopping by, and we'll ask you to come back again next week. Let's all choose safety today. This is Jim, and I am out.